So in this section, we talk about simple and compound interest and also growth and depreciation. So let's start with simple interest. Simple interest is the interest calculated on a principal at a given rate and for a number of years. And this is the case where you have some money, you've put it aside, you only get paid the interest at the end of the period that you put the money in the bank. The formula for simple interest is I equals PRT divided by 100. I represents the interest. So I is the interest earned on the money. P is your principal. This is the money that you originally put in the bank. Money you put in the bank, okay? R is your rate, usually your bank rate or your savings rate. And T is the number of years that the money is going to be in the bank. Okay, so you multiply the principal times the rate times the time, and then you divide by 100, and that gives you your simple interest. Okay, so simple interest is always calculated with reference to the original amount borrowed or lent. So that's, remember that original amount, that's your principal. Okay, all right, here's an example. It says find the simple interest on $2,500 for 2.5 years at 6% per annum or per year. What is the total amount to be repaid after 2.5 years? Okay, so the P is your principal, is $2,500. The rate is 6%, and your time is 2.5 years. And you may want to use a decimal there. So how about 2.5 years? Okay, so first we're going to calculate how much interest was earned. And the interest is the principal times the rate times the time divided by 100, right? So that's 2,500 times 6 times 2.5 divided by 100. And so we're going to cancel these zeros here. We've done that before, okay? And then we have 25 times 6. So 25 times 6, which is 150, right? And then that's times 2.5. Okay, so let's go ahead and do this. Multiplication here. Okay, and so then we have that the interest earned was $375. Okay, so the total amount that's repaid after 2.5 years is the principal, so the amount is the principal plus the interest. So your original 2,500 plus 375. So that is $2,875. Okay, let's try the next one. Okay, for this one says calculate the principal amount borrowed if the simple interest on the loan is $500 for a time period of 2 years at 5% per annum or per year. Okay, so we're looking for P. We don't know what that is. That's our unknown, okay? We know the interest, which is 500. We know the time period is 2 years. And we know the rate, which is 5%. Okay? And remember that our simple interest form is the formula is I equals PRT t, these are all multiplied, divided by 100. So let's put in what we have. We have 500 equals, we don't know p, looking for p, times, okay, r, which is 5, times t, which is 2, divided by 100. Okay, so we're going to multiply these two first. Here we have 500 equals, 5 times 2 is 10. So p times 10 over 100, right? Okay, and so again, I like to reduce those. So we have p, some number, divided by 10 equals 500. And so p must be 500 times 10, or $5,000. So your principal was $5,000, and you made $500 simple interest on that after 2 years. Okay, next. Angela borrowed $30,000 from a lending institution for purchasing a house. The total amount, including simple interest, that Angela has to repay after 3 years is $33,600. What is the rate of interest per year on the loan? So the total amount that she pays, is principal plus interest. And we know that the total amount was given as $33,600, and we know that the principal, that what she borrowed, was $30,000. So let's use that first to find the interest. So if we subtract 30,000 here from both sides, then we're going to get over here $3,600, which is our interest. Now remember that our simple interest formula is interest equals principal times rate times time divided by 100. So let's substitute in what we know. Let's come over here. The interest is 3,600. The principal we know was 30,000 times rate is what we're looking for, and the time is 3 years divided by 100. And so again, I'm going to reduce here a little bit, that 100. So I have 300 times 3 times r. So 300 times 3 is 900. So 900 times the rate has to equal 3,600. And so what number do you multiply times 900 to get 3,600? And if you said 4, you are right. So the rate is 4%. Okay, next. Christina borrowed $10,000 at 8% simple interest. She paid an interest of $2,000 when she repaid the loan. What was the period of the loan? So we're looking for T this time. So they told us that's 2,000. P is the principal, the amount she borrowed, which was 10,000. R is 8%, and we're looking for T. So remember, I equals P times R times T over 100. So let's see, 2,000 is equal to 10,000, that's our P, times 8 times T over 100. Reducing the zeros here, then we have 100 times 8, so 800 times T is equal to 2,000. And so we need to see what number we multiply 800 times to get 2,000. So let's divide by 800 so that we can figure out what the time is. Okay, then these will cancel. This will be a 1T. And here the zeros go away again. And then we have to divide 8 into 20. And 8 goes into 20 twice. That's 16. And so remainder 4. So this looks like it's 2.5 years. Because 4 over 8 is a half. So T equals 2.5 years that she had the loan. Okay, so those examples we just did were simple interest. And again, I want to remind you that simple interest is always calculated with reference to the original amount borrowed or lent. So in other words, your principal amount doesn't change. In all of these problems, we had one set principal, and then we computed the interest at the end of the loan period. Okay, so before we start talking about compound interest, let's do one more example here. It says, if simple interest is calculated for 3 years at 10% on $1,000, how do we calculate that? Okay, well, our principal is 1,000. Our rate is 10%. Our time is 3. And so our simple interest is principal times rate times time over 100. So 1,000 times 10 times 3 over 100. And reducing here, we get 10 times 10 times 3. 10 times 10 is 100, times 3 is 300. So this tells us that in simple interest, the interest earned when you have $1,000 put away at 10% for 3 years would be $300. Okay, now let's talk about compound interest. Compound interest is calculated differently. Every year, the interest is added to the principal, and the next year's interest is calculated on the new principal. And this is more like what you're used to with banks. So let's talk about this. So the calculation for compound interest for 3 years will be, so the same examples. Remember, the first year, our principal is $1,000. So you start out with $1,000. Our rate is 10%. Okay. But now we're going to look at the first year only. So that's going to be T equals 1. So we're going to, our interest will be P times R times T over 100. So 1,000 times 10 times 1 over 100. And canceling here, we get $100. So the first year, you make $100, okay? So now what happens is for year number 2 in the bank, you don't have any longer, your principal is not just 1,000 anymore. Now you have $1,100. So your principal changes. It's now $1,100. Your rate is the same, and your time is still a year. So now let's calculate the interest at the end of year 2. So interest equals principal times rate times time over 100. So 1,100 times 10 times 1 over 100. Canceling zeros, we get 11 times 10 or $110. Okay, so your interest for year 2 is $110. Okay, the third year comes. Now your principal is in the bank is no longer $1,100. Now you have $1,100 plus 110, right? This was your interest from last year. You add those together and you have $1,210 in your bank. That's your new principal. Your rate is still 10%. Your time is a year. So the interest on this third year is principal, which is 1,210, times your rate, which is 10, times your time, which is 1 year, divided by 100. And then you are going to reduce that 10 and this 10. So we have here $121. So at the end of 3 years, how much interest have you earned? At end of 3 years, you have earned, well, year number 1, you earned $100. Year number 2, you earned $110, and year number 3, you earned $121, or when you add those together, you have $331. Okay, so that's different than what we got in the simple interest, because the simple interest, if you recall, for that we got that we earned $300. Okay, and this is the interest on the principal of 1,000. The extra $31 here that you get with the compound interest is actually going to be the interest on the interest that you earned before. And that's the difference. You're earning more money with the compound interest than you do with the simple interest, right? Okay, and so here's the formula for compound interest, which you can see is very different from our simple interest formula, right? So remember, our simple interest was I equals P times P. I equals P times R times T over 100. That was simple interest. Compound interest is the amount equals the principal times 1 plus the rate divided by 100 to the n. Okay, and n is the number of compoundings that you're going to have. Okay, so this gives you the amount left in the bank after you compound. Okay, this would be the way for us to calculate our 331. So let's actually apply that. Let's look at that. So P, the original principal was 1,000. So you do use your original principal in your formula for compound interest. R is 10%, okay? And then N is 3 because we compounded for yearly for 3 years, right? So 3 times we calculated interest, so that's your N. So A equals 1,000 times 1 plus 10 over 100 to the third. Okay, so this is 1,000. Let's do this parenthesis here. 10, just cancel. We have 1/10 here, so 1 and 1/10. If you like decimals better, don't know, 1.1. 1 and 1/10 is 1.1 to the third power. And so we're going to have to do this exponent next. And so if we're doing this by hand, then we are going to have 1.1 times itself is 1.21, and then times another 1.1. Let's see what we get here. Okay. All right. 1, 2, 3. So 1.331. And so then we take that. So that's your 1.1 cubed. So then you take that times 1,000. Okay, and multiplying 1.331 times 1,000 moves the decimal 3 places to the right. So you end up with $1,331. That's your amount in the bank. And so remember, our original principal was $1,000. So if you want to know what your interest was, subtract those two, and there is our $331. Okay? All right. Example. Betty wants to partly finance the purchase of a car. She is thinking of taking a loan for $5,000. The interest rate is $8,000 compounded annually. The period of the loan is 2 years. What is the compound interest that Betty will have to pay after 2 years? So Betty's principal is $5,000. Her rate is 8%. Her loan period is 2 years. Now, as soon as they said compound interest, then this 2 years, because you're compounding annually, so you're only compounding once a year, then this 2 years is our N. Okay, because N is the number of compoundings. So what is the compound interest that she will have to pay? So amount, so we're going to find the total amount she's paying, and then we'll subtract to get the interest. So remember, it's principal 1 plus rate over 100 to the n. Okay, so 5,000, 1 plus 8 over 100, and then n is 2. And then 8 over 100, because if we're going to square, I don't know, you may prefer a decimal. This is 1.08, right? 800ths is 0.08. Then we're going to square that. So we're going to do that next, because exponents go before multiplication. Okay, so we are going to do all this. Okay. And hope that Jackie doesn't make a math error. Let's see, 1, 2, 3, 4. Okay, so I got 1.1664. That's this number squared. And we need to multiply that answer by 5,000. So let's put 5,000 over here. And that's 1, 2, 3 zeros for this. And then 5 times 4 is 20. Carry the 2, 5 times 6, 30, so that's a 2, carry 3, 33, carry 3, 8, 5. And it's 1, 2, 3, 4 decimal points. So $5,832 in the bank, or she's got to pay for her car. And since 5,000 was the original loan amount, when you subtract that $832, that is her interest. Hope that makes sense. Okay. Let's do a couple more and then we'll be done. Let's see. A certain type of bacteria grows at the rate of 60% in an hour. If there are 10,000 of these bacteria initially, what will be their number after 2 hours? Well, here's the thing. Growth, population growth like this, or bacteria growing, things like that, that is compound interest. I mean, it's the same formula, okay? So you're going to use your same formula, okay? And so P is going to be your original population, if you want to think of it as that. And that's your 10,000, okay? So P is 10,000. Your rate is 60%, so 60 over 100. And your N, now we're talking hours, okay? So we're looking at it for 2 hours. Okay, so then in here, I'm going to reduce the zeros to get 6/10, and so you know that that's 1.6, and we have to square that, order of operations. So let's see, 1.6 is, okay, 2.56. Hopefully I didn't make a mistake there. Okay, so 2.56, and you're going to multiply that times 10,000, which moves the decimal 1, 2, 3, 4 places. See 4 zeros? This gets moved 1, 2, 3, 4 places to the right, and so we end up with 25,600 bacteria at the end of 2 hours. Okay. And our last problem. It says sometimes a quantity does not grow or appreciate. It only reduces or depreciates. For example, the value of a car reduces with time. The formula for this is almost the same, except that R has a negative sign. See that? So for depreciation, you need a negative sign there. Okay, the rest is the same. So it says, a machine in a factory costs $25,000. Its value depreciates by 10% every year. What is its depreciated value at the end of 3 years? So your original amount is $25,000. That takes the place of your principal. Now you need a subtraction sign here because you're depreciating, and it's 10%. And we're looking at 3 years. So here, again, we have 1/10. Okay, so here be careful because here's 1 minus 0.1, which is 0.9, 90, right? 90 over 9 over 10. And we're going to have to cube that. Okay. So, well, let's see. 0.9 squared is 0.81 times another 0.9 is 0.729. That's what goes here. And then we need to multiply that times 25,000. So 0.729 times 25,000. 1, 2, 3 zeros, 5. Boy, okay. Are you still following here all this arithmetic, which I hope I didn't do too fast to do correctly? 1, 2, 3. So we get 18,225 depreciative value in 3 years. Okay, well, I hope that helps you with this section. You will see some of these in the final exam, so make sure that you know them well.